another lesson from Chemistry Pace 5, 1125. And I'm going to look here at page T. Let's jump ahead to question 34, and then that'll actually help you with number 33 and 34, and then you can do the whole next page. So right here, we're going to look at this question, but then when you turn the page, wow, there's two more pages of these, pages U and V, although we do want to do some of these where we have to do from grams to moles, right? We'll do one of those in another video. But let's start with this equation. Now they give us this equation, but they tell us that it's not balanced. And just looking at it, I can tell right away it's not balanced because I have 2 lithium here and only 1 lithium here. So to balance that, let's see, if I put a 2, big 2 out front, now I can't add a 2. Remember, you can't add a 2 inside the formula. You can't make this Li2OH. Because the LiOH is already, that's the way it connects. That's the recipe to make that in, and you can't change that. But I can change the coefficient, the number out front. And so if I have 2 of these, now I have 2 lithium, 2 lithium. Let's see about carbon. 1 carbon, 1 carbon. Good. Let's see how many hydrogen I have. 2 times 1, so I have 2 hydrogen. And over here, none here, but I have 2 hydrogen here. So we're good so far. Let's look at the oxygen. 1, 2, and then 2 times this will give me 2 oxygen here. So I have a total of 4 oxygen in the reactants. Let's look at the products. We have 3 oxygen and 1 more oxygen. Yay! So we have 4 oxygen. So by making 1 change in a coefficient, we have balanced the equation. Now, I think in other paces, you have learned about balancing equations and changing the coefficients, so hopefully that was just a quick review. Now let's talk about this particular type of problem, and that's using the stoichiometry. Not a great word? When your dad asks you tonight what you learned in school, you can say, I learned about stoichiometry in chemistry. And actually, stoichiometry is one of the most powerful tools that's used in chemistry and in real life. Chemists and in all sorts of fields of science, they use this exact process that we're going to be going through to figure out recipes for how much product will be formed or how much reactant is needed to cause a reaction to form. So what's given in this problem 34 is that we have 5.25 moles of the lithium hydroxide, okay? And the question is, if I have plenty of carbon dioxide, we're not worried about that, how much lithium carbonate will be formed? And we want the answer to come out in moles, okay? So we're going to use what we learned in the previous video, and that is setting up the molar ratios. And because I want the answer to come out in lithium carbonate, and I'm starting with this one, we're going to put the lithium carbonate on the top and put the lithium hydroxide on the bottom. Now, what were the numbers here? We have 1 for lithium carbonate, 2 for the lithium hydroxide. All right? Then, in front of it, we're going to multiply times 5.25 moles of the LiOH. All right? So this is going to cancel against this, and basically just multiply 5.25 times 1, divide by 2, all right? And then the answer comes out to be 2.63 moles of Li2CO3. Not a very good 3. All right, there we go. So, again, you start with what's given. Whatever that element or compound is, that's going to go on the bottom of the ratio. That's very important. Whatever you start with goes on the bottom of the ratio. The thing you want to find out, all right, that's going to go on the top. And then you look at the balanced equation to see what the coefficients are. So this is a 1, so that's why I put the 1 there. We found out that this needed to be 2, so I put the 2 there. And then you just multiply. 5 times 1, 5.25 times 1, take that number, divide by 2, and we get 2.63. So you can use that same process now to do all the other reactions. Now when you do problem 31, it's going to take a little more work to balance the equation, and you're not going to have to do all the mole ratios like we did up here at the top of the page. We only need to do the one that will help us solve that problem, because that one is saying how many moles of H2SO4 will react with iron hydroxide. You put the iron hydroxide on the bottom, and the Fe2SO4 goes on the top. That's after you balance the equation, then you put the coefficients in and just solve, all right? Once you get the answer, that number is the number of moles, and then you're done with that problem. I'm going to do one more video where we do a problem on the next page involving grams, because that does add a level of difficulty and make it a little more confusing. All right, so try a few of these problems, and then I'll meet you back here in a few minutes to do a problem on page U.